In this video, we're going to work example problems where we solve linear equations in one variable. Now, before we get started, let's remind ourselves what exactly a linear equation is, not just in one variable, but in any number of variables. So the general idea is that a linear equation is a subset or subcategory of polynomial equations. And so but a polynomial equation was where you go to each variable and the exponents on every single variable in the entire equation are going to be some whole number exponent. So like 0, 1, 2, 3, 4. So this is a polynomial term. This is a polynomial term. Okay, but even with multiple variables, this is a polynomial term as well. Each exponent is a whole number. So we say that this term has degree 2, this term has degree 4, and this term has degree 3. 2 plus 1 is 3. So if every single term it has these whole number, all the variables has whole number exponents in the entire equation, then it's a polynomial equation. And then, but if it's in 1, 2, 3, or however many variables, you just count the number of total different variables. A linear equation is, again, it's a subcategory of polynomial equations, and it's just to where every exponent, every variable, the exponent on every variable is going to be 1. But that's kind of confusing because then it makes it seem like, well, this is a linear term. Well, no, because it's more specifically, the linear equation is going to be to where the degree of every single term is going to be 1. So here the degree is 2, so this isn't a linear term. So it's like, yes, every single variable is raised to the power 1, but also the total degree of every term is just going to be 1. So again, the degree would be 2, so no, that's not linear. So but if you had plus 5y minus z is equal to 7, well, the degree of this term is 1, the degree of this term is 1, the degree of this term is 1. So this would be a linear equation in 3 variables. Okay, and so that's the idea. The degree of every single term is 1 or 0, like, okay, so this would be for x to the 0 you can think about. But if it's a 0 degree term, then you're dealing with a constant. But you can see this is a linear equation in one variable. Every single term, wherever the variables are, it's the variables raised to the power 1, but the whole term is degree 1, right? Again, I just want to stress this, even though both of these variables are raised to the power 1, well, no, but this is not linear because the degree of this term is 2. Okay, now to solve these equations, we're going to use these properties of equality. Now, but we use these properties to solve not just linear equations in one variable. We use these to solve any kind of equation in any number of variables. So this isn't unique to just linear equations or in one variable, etc. So this isn't just unique to linear equations in one variable. Okay, so the properties of equality just say that we can add or subtract, if you make C negative, the same thing to both sides of an equation and you don't change the equation. So C they say it's a number here, but it's really any expression, any variable expression represents a number. So you can add or subtract any expression or number to both sides of an equation, and it doesn't change. You have an equivalent equation. And the same idea with you can multiply or divide the same thing by both sides of an equation, and you still have an equivalent equation, except you can't multiply both sides by 0. Then it doesn't apply. Okay, now an equivalent equation means that the solution sets are the same. That's the meaning of an equivalent equation. The solution sets are the same. And so we use these properties of equality to kind of condense down the equation until we get it to an extremely simple equivalent equation that we can just read off the solutions. Okay, so the general process that we're going to use here, not to solve any kind of equation, is we're going to simplify the left and the right sides of the equation as much as possible, so distribute, combine like terms, etc., and then use the properties of equality to isolate the variable terms on one side and the constant terms on the other side, as well as get a coefficient of 1 in front of the final variable term to where you're just left with the variable on one side and then some number or numbers on the other side. And so you can just read the solution. That's the general process we're going to use to solve any kind of equation, really. And so, okay. So this equation, it's already fully simplified on the left and the right. So next, let's isolate the variable terms on one side and the constants on the other. And so the way it's typically done is you isolate the variable on the left side because we read left to right. So, okay, what we can do is if we add 4 to both sides, okay, so we haven't changed the equation. It's an equivalent equation. The solutions are the same. Okay, but it looks more complicated. So why did we do this? Well, no, because minus 4 plus 4 is 0. So now we've isolated the variable term on one side, and then 20 plus 4 is 24. So now we have a simpler equation than what we started with. But these two equations are equivalent. So that means the solutions are the same, but now we're closer to figuring out what the solution is. So now if we want to get a coefficient of 1 in front of the x, we can divide both sides by -6. And -6 divided by -6 is positive 1. And so we're left with -4. 24 divided by -6 is -4. Okay, so there we go. So we haven't changed the equation at all. This equation is equivalent to the original equation. This is still just an equation here. And so, okay, since they're equivalent, that means the solutions to this equation are the exact same as the solutions to the original equation, which is what we're trying to figure out. Well, okay, what's the solution or solutions to this equation? Well, we can see there's only going to be one solution here. If you take all of the potential numbers on the number line, what are all of the numbers that would satisfy this equation? Meaning you plug x into both sides of the equation, and when you simplify, you get the same value on both sides. Well, it's going to be -4. You plug -4 in here, you get -4 is equal to -4. That's the only solution, which means since these equations are equivalent, that's going to be the solution sets are equivalent. So since the solution set to this equation is one number -4, then that's the solution set to the original equation. Now, when it comes to linear equations, you don't technically have to check your solutions, because if you didn't make any math mistakes, then the solution you got is going to be correct. But as we saw, like with rational equations, and there's other types of equations where that's not going to be the case. Like even if you didn't make any math errors, you're going to have to check your solutions. Okay, but we can go ahead for these first few problems. We can check the solution. So, okay, how do you check to see if a number is a solution to an equation? You just plug in that number for the variable into both sides of the equation, simplify, and if you get the same value on both sides, then that's the solution. So -6, we plug in -4 here. Okay, 24 minus 4 is equal to 20, so 20 is equal to 20. There we go. X is equal to -4 is, that is the solution. Okay, let's just start by simplifying both sides, like, so distributing, combining like terms, etc. So the left side here is fully simplified. So the right side, let's distribute this -3. Okay, so 4, let's see, 7 minus 3 is 4. Okay, so now we're fully simplified on both sides. Now let's apply the properties of equality. So, I like to have the variable on the left side. I think that's the most common way it's done, because, again, we read from left to right. So let's add 12t to both sides. Okay, and so what we're going to get there is 12t plus 4 is equal to just 4, right? Because minus 12t plus 12t is 0. Okay, now let's subtract 4 from both sides. So we've got 12t, 4 minus 4 is 0, but we got 0 on both sides. Okay, now let's divide both sides by 12, and we get that t is equal to 0. And so there we go. If we didn't make any math errors, that's going to be the solution. And with just to note, we'll learn more about this later, but with linear equations, there's only going to be one solution. But there's other types of equations where you can have more than one solution. So if we didn't make any math errors, t is equal to 0 is the solution, but we can go ahead and check. So it's good practice to check. 4 times 0 is 0. Okay, so 4 is equal to 7 minus 3. So 4 is equal to 4. That's the solution. There we go. Okay, let's just start by simplifying both sides as much as we can. So distributing this minus 6 plus 12 plus 3 is equal to 9 minus v minus 4. Okay, let's combine like terms. So minus 6v plus 12 plus 3 is 15. And then 9 minus 4. Okay. Now let's add v to both sides. Okay, so v minus 6v is minus 5v. Okay, now let's subtract 15 from both sides. Okay, minus 5v is equal to minus 10. So now let's divide both sides by minus 5. V is equal to 2. Okay, so that's the solution if we didn't make any math errors, but we can check. So 2 minus 2 is 0. So we're just left with 3 on the left side. And then 9 minus 2 plus 4 is 6. So 3 is equal to 9 minus 6 is 3. There we go. Okay, the left side is fully simplified. Let's simplify the right side. So 4x minus 4 minus 1 minus 2x. Okay, now let's see. 4x minus 2x is 2x. Minus 4 minus 1 is minus 5. Okay, now we can subtract 2x from both sides. And we're going to get minus 3 is equal to minus 5. Okay, so what does this mean? This is different. Well, remember that we haven't changed the equation. Like we haven't. All we've done was simplify. When you simplify, we haven't like so. Okay, when we got to before we subtracted the 2x's from both sides, we got here. Well, all we did was just distribute and combine like terms. This expression is equivalent to this expression, right? We haven't changed anything. And then again, when you do properties of equality, you don't change anything either about the equation. So this equation is equivalent to the original equation. What does equivalent mean? Equivalent means that the solution sets are the same. So that means we can say, well, what's the solution set of this equation? And we know it's going to be the same as the solution set of the equation we're trying to solve. So what's the solution set of this equation? What values of x from we're choosing from the real numbers, you know, we could think about later choosing from all the complex numbers, but we're sticking with real numbers. Of all the real numbers, what values can you plug in that would solve this equation? Well, there are none. Minus 3 can never be equal to minus 5. So this is never true, and so that means this is never true. This might be confusing, though, because it's like, well, wait a minute, there's no x's here. What does this mean? Well, no, the idea is like you can think about like when we subtract and add things to both sides of the equation, we're kind of taking out all the symmetry. And so in this case, the idea was that it was like the exact same proportion of x variable on the left and the right side of the equation was contained on the left and the right side of the equation. So whatever you did in terms of the x variable, whatever you did to one side of the equation, you do that exact same thing to the other. So it's like cancel each other out. And so the only difference is the non-variable terms. How do those relate? That's going to be the only difference. And so that's when we subtracted out and added both sides, things to both sides of the equation to kind of take out the symmetry. We're left with, well, okay, here's what's remaining. And so it's just telling you no matter what value of x you plug in, they're never going to be equal. And so there's no solution here is what you say, but the type of equation that this is called a contradiction. If the equations we solved previously where we got, one solution, those are called conditional. And all conditional means it's not that you got one solution. Conditional means that as long as you of the entire all the potential solutions, like all real numbers in those cases, if just a portion of those are solutions and then another portion aren't, then that's called conditional. If there's no solution, it's called a contradiction. If all of the potential solutions, that all of them are solutions, then it's called an identity. Okay, so let's see. We can go ahead and flip this to get the variable term on the left side. Okay, now let's subtract 30.2 from both sides. So we've got, let's see, 4.5x is equal to, so 30.2. If we subtracted these, we're going to get 27.9, but it's going to be negative 27.9. Now let's divide both sides by 4.5. And so we're going to get negative 6.2. Okay, so we can check this. So this times negative 1, and then times 4.5 plus 30.2, 2.3. There we go. Okay, here we can, let's write this as 5 over 100, and so that's going to be 1 over 20. So 1 over 20 y plus then 2 over 100 is going to be 1 over 50. And then we've got 6,000 minus y is equal to 270. So yeah, we looked at examples in the textbook where if you've got a linear equation, really in any number of variables, you could think about doing this. But we were focusing on one variable. If you've got fractions, then what you can consider doing is multiplying both sides of the equation by the least common denominator of all of the fractions. So let's go ahead and do that. I like doing that. So now another way you can multiply like the notation you can use for multiplying both sides of an equation by something is you can think about multiplying the entire equation. You can write it this way. I like to do this. So we're going to multiply this entire equation by 100. Okay, so 100 divided by 20 is 5, so we've got 5y, and then this is going to be 2, 6,000, and then let's see, 2, 7, add 2 zeros. Okay, now let's simplify the right side. So, okay. Now 5y minus 2y is 3y. Okay. All right. Now let's subtract 12,000 from both sides. So 3y is equal to, so 27,000 minus 12,000 is going to be 15,000. Now we can divide both sides by 3. So we've got 3 times 5 is 15. And so that's going to be 5,000. So y is equal to 5,000. And I'm going to stop plugging these in now. So because again, if you didn't make any math errors, then you know your answer is correct, but that's not always the case. Sometimes you have to plug your answers back in. But with a linear equation, you technically don't have to. Okay, so let's simplify the left side here. Let's distribute that 2. Okay, then we've got, let's see, x and minus 3x plus 30. Okay, so we've got 10x minus 12, and let's see, minus 2x plus 30, x minus 3x is minus 2x. Okay, so we've got, let's see, 10x minus 12 is equal to minus 8x plus 120. So now, all right, let's add 8x to both sides. We get 18x minus 12 is equal to 120. Now let's add 12 to both sides. So 18x is equal to 132. So now divide both sides by 18, and we get 22 divided by 3. Okay, let's distribute this minus on the left here. Okay, let's distribute this 4. And then we've got, okay, now let's 4w minus 2w, and then 4 minus 10. Okay, now let's add 6 to both sides. And we're left with 2w is equal to 2w. Now, I mean, you could subtract 2w from both sides, and you're going to get 0 is equal to 0. So what's this? Well, okay. Again, these are equivalent equations. This equation is equivalent to the original equation. So what are all the solutions to this equation here? Well, you can plug in any value of x that you want. This is always going to be true no matter what, or any value of w. So that means same thing here. You could plug in any value of w that you want, and it's going to satisfy the equation. So all real numbers, and this is called an identity. Okay, let's multiply this by entire equation by 4. So we're going to get x minus, and let's see, 4 divided by 2 is 2 times 3. So okay, is equal to 8. Now you add 6 to both sides, and you get x is equal to 14. And this is, conditional, right? This is the conditional case. It's a of all the potential solutions, a portion of them are solutions and a portion of them aren't. Okay, let's clear the fractions. You don't have to clear the fractions by multiplying the entire equation by the least common denominator. You can just do it with the fractions if you want, like do all the additions with the fractions, but I like to clear the fractions. So, okay, we can see here we're going to have least common denominator should be 12. So we've got, let's see, 6w minus, and then 9, and then 4 times 2, and then, okay. Now, we can add 9 to both sides. So 6w is equal to 8w plus, what is this going to be, 33. Now we can subtract 8w from both sides, and we're going to get minus 2w is equal to 33. Now we can divide both sides by -2. So there we go. Okay, let's see. Let's multiply this entire equation by 20. So we're going to get 4 times y minus 1 plus 5y is equal to 10 times y plus 3 plus 20. Okay, now let's just solve this like normal. So distribute the 4 on the left side here, distribute that 10. Okay, let's continue to simplify. So 4y plus 5y is 9y. And then 30 plus 20 is 50. Okay, we can subtract 10y from both sides. We get minus y minus 4 is equal to 50. Okay, let's see, plus 4 plus 4. So minus y is equal to 54. Multiply both sides by minus 1. And we've got y is equal to minus 54. Okay, let's see. Let's multiply this by 20. So we have 5 times n plus 3 minus 4 times n minus 2 is equal to 2 times n plus 1. Okay. So 5n plus 15 minus 4n plus 8 is equal to 2n plus 2 minus 20. Okay, 5n minus 4n is n. Okay, 15 plus 8. Okay, and then 2n, and then we have minus 18 over here. Okay, let's subtract both sides, 2n from both sides. So n minus 2n is minus n, is equal to minus 18. So now we can subtract 23 from both sides, and you got minus n is equal to minus 41. So now multiply both sides by minus 1, and you've got n is equal to 41. Okay, let's multiply this by the entire equation by 4. So we have 2x plus 12 is equal to x plus 4. Okay, let's subtract x from both sides. 2x minus x is x. Okay, let's subtract 12 from both sides. So x is equal to minus 8.